Okay, number one, through -1, -4, parallel to y equals 3x plus 4. Parallel means same slope, different y-intercept. Yeah, they're all on the tables. I were on the table, so just take one from the table. Parallel slope is 3. X is -1. Y is -4. No, probably where it always is back there, unless somebody stole it. Oh. Y equals 3x minus 1. Okay, number 3, box. That's a wonky box. Okay, so make sure you've got k squared here. First of all, this should be negative. This should be negative. And then make sure you've got this as a positive. Okay, combine. I fear that my pencil is, or pen is running out. 42k squared minus 54k plus 12. Okay, any questions about those, any of those problems? You guys good on those two? You got the parallel thing happening, I hope. Okay. So today we're going to do a math problem that's inspired by the Of Mice and Men book. Did you guys read that yet in English class? Sophomore year? Okay. Um, so there's these two guys and they want to make like or one of them wants to have bunnies, a lot of bunnies. Anyway, their names, I think it's Fred and Joe. No, I'm thinking of the Weasleys. What are their names? George and Lenny. And they want to have like a bunny farm. And so what we're going to do today is take scenarios of different, uh, different growth of how many bunnies. We're gonna have to draw diagrams out and do tables. It's not hard, I promise. And homework is 6 through 10. That's in the CPM book, and that is the joke. It says, "Can I copy your homework? I ate mine." And I have two beloved golden retrievers at home, and I could totally dress at least one of them up like that. He is like the coolest dog ever. Yeah. Anybody have a golden retriever? You had one? They're super cool. Okay, good news. All of our work today is in the packet. So if you guys could find this. And then we're going to read this scenario out of the book. Okay, here we go. In the book of Mice and Men by John Steinbeck, two good friends named Lenny and George dream of raising rabbits and living off the land. What if their dream came true? Suppose Lenny and George started with two rabbits, and during the first month, those two rabbits had two babies. Also, suppose that every month thereafter, each pair of rabbits has two babies. With your team, determine how many rabbits Lenny and George would have after 1 year. Represent the situation with a pattern of growth, diagram, and a table. State the assumptions you made, compare any patterns that you investigated previously. Okay, so they start with two bunnies. I am going to represent my two bunnies with two little circles. So just imagine that's two bunnies, and I'm going to call this month 0. Okay. And then down here, I'm going to say at month 0, they had 2 total rabbits, and that makes my table start at 2. Okay, any questions so far? Now it said each pair of rabbits has 2 babies. So we're going to draw month 1. And so that means that these 2 rabbits have 2 babies. Okay, so total rabbits for month 1 is 4. And my expanded form here is 2 times 2. So I'm just going to put a 2 here for my expanded form. And then 2 started with 2, had 2 more. Okay, now month 2. This is where we have to pay really close attention. Okay, this is all of the bunnies from month 1. I just copied this over here. So this is all the bunnies from month 1. And the 2 new bunnies had 2 bunnies. This is the part where you have to be careful. The 2 original parent bunnies also had 2 new bunnies. Okay, so 8 total rabbits, and 2 times 2 times 2 is my expanded form. Okay, I think you're probably getting the hang of it. Let's draw month 3 here. Month 3 is, we've got to be really careful. Okay, so we're just going to copy this picture from month 2. Okay, now the very original pair has 2 bunnies. This new pair has 2 bunnies. This pair has 2 bunnies. And this pair has 2 bunnies. Two, 4, 6, 8, 10, 12, 14, 16. Does that make sense with our pattern? Okay, so 2 times 2 times 2 times 2. Okay, so I don't know about you, but I don't really want to draw month 4. That seems like it's going to be pretty crazy. But we now know the math. So I'm going to put a little arrow here that says times 2. You can tell it's timesing 2 each time. 32. 2 times 2 times 2 times 2 times 2. What? 64, yep, good job. Okay, now over here, um, I want to just make a note that this is 2 squared and this is 2 cubed. This is 2 to the 4th and this is 2 to the 5th. But the way we write the rule is a little different. So y equals, and what you do, this is called AB to the x. You put the start in the front, then the multiplier, and then to the x. Okay, so let's make little arrows. This is my start. And this is my multiplier. A little bit different from mx plus b. This is not the same thing because it is multiplying instead of adding. Okay. You guys okay? All right, so let's go over to, why is this number 4? What? Oh, I did this in the wrong spot, didn't I? Okay, okay, that's fine. That's fine. That's fine. Just gonna make this one 3. Go over to 2 here. Okay. Case 2. Start with 10 rabbits. Each pair has 2 babies per month. Start with 10 rabbits. Each pair has 2 babies per month. I did mine in the wrong spot. It's totally fine. Okay, so start with 10 rabbits. So this is what I like to do. I like to pair them off into 5 pairs. So there's my 10 rabbits that I started with. And that means my start is 10 and my total rabbits is 10. Okay, now month 1. I feel like we all in this class can probably catch the pattern after the first month. We probably don't need to draw all 3 months, but okay, so there's the original 10 bunnies, and each pair has 2 bunnies. Okay, how many total rabbits are there? 20. Okay, and what we're going to do in expanded is we're going to write 10 times 2. Okay, so let's see if we can follow the pattern. So what is the multiplier? Perfect. Okay. Let's see if we can fill this out without needing to draw any more bunny diagrams. So 40, 80, 160, 320, 640. Okay, this is how we're going to write this. 10 times 2 times 2. 10 times 2 times 2 times 2. 10 times 2 times 2 times 2 times 2. Okay, rule y equals, what is my start? 10. And then multiplier 2 to the x. Are you getting the hang of it? It's really not that bad. Now, I don't know how they are going to deal with 640 rabbits. I mean, that gives me some kind of level of underlying anxiety. Do you guys have any experience with rabbits? I had a rabbit. It was high maintenance and it was one rabbit. Oh, that's terrible. Okay, case 3. Start with 2 rabbits. Each pair has 4 babies per month. This is going to be interesting to draw. Start with 2 rabbits. Each pair has 4 babies per month. So find wherever you're going to put case 3. Mine's going to be here because I screwed it up, but that's okay. Because I'll have it all somewhere. Okay. Month 0. Said it start with 2. Start with 2, 2, 2. Now, what do you think the multiplier is? You have a couple of good guesses there. Okay, so here's month 1. There's my original 2. It says each pair has 4. So I'm going to split them off into 2 pairs. So each pair has 4 per month. How many total is there in month 1? 6. So it's times 3. Should we draw month 2 or are you okay without it? But do you know mental math times by 3? So 16 times 3 times 3. Good. Times 3. Nice. Close. 1458. Did I do the same thing twice? Wait. All right, so what is the rule? Yep, 2 times 3 to the x. Okay, so before we do the last one, if y equals mx plus b is linear, does anybody know the vocab word for ab to the x? You probably don't. It's okay that you don't. They're called exponentials. So these are not lines, they're going to be exponentials. Okay, last one, flip over to wherever you're going to put case 4. I get to put case 4 in the actual spot where case 4 was supposed to go. That's fine. It's fine. Totally fine. Okay, start with 2 rabbits. Each pair has 6 babies per month. Oh my goodness, that's so many rabbits. Okay. Month 0. Start with 2. month one. There's my two, and it says that each pair has six. Okay, so how many are there total here? 8. And so my multiplier is times 4. 32, 28. Took me a minute. Okay, now we're not done. We're not done. Don't get excited. After you get this, flip to the graph, please. There's a graph right after. And we're going to graph the 4 cases out, but just as far as we can, because they're not all going to fit on the, clearly are not all going to fit on the graph. So we're just going to do our best. Okay. So find this, if you will. Okay, and so looking back, let's start with case 1. Find your case 1 so you can flip, like keep your finger in the packet so you can fold back to it. Case 1, month 0 was 2 rabbits. It's going to be really hard to grab that. Just make a dot that's like not exactly at 0, 0, but like pretty darn close to 0, 0. Okay, if you're wondering what I'm looking at, I'm looking here. This is case 1. Month 0 was 2 rabbits. Month 1 is 4 rabbits. So come over here to month 1. And these are going by tens. So you want it to be just under half a box. Okay, month 2 is 8 rabbits. So that will be just under a full box because they're going by tens. Month 3 is 16. So that's like 1.5 boxes. You guys, I love your anticipation, but these are not lines. So I said they were exponential. They're not linear. Just a minute ago. 4, 32. So 3 boxes and a little bit. And then 5 is 64, which is there. Okay, just note, we're not going to be able to fit all of the points on this graph paper. We're just going to graph what we can. Okay, so now find case 2. What was month 0? 10. So 0, 10. It's going to be right here. Each box is 10, remember? Okay, so month 1 was 20. Month 2 was 40. Month 3 was 80. Month 4 is 160. And month 5 is 320. Okay, case 3 starts at 2 again. You already have that one graph. And then 1 is 6, which is just going to be a tiny bit above the one you already have there. 2 is 18, which is going to be right below the 20. 3 is 54. 4 is 162. And then 5 is 486. We can't fit that on the graph. So we're just going to do our best. The last one. This one's already here. 8. 32. We can only do up to 3 on this one, huh? Look at your own table, it's not my screen. You have the data in your table. The last thing first. These are not locked. Okay, so if you're not adding the same thing each time and multiplying the same thing each time, they're called exponentials and then they recur. Isn't it?
Yeah, they're.
These do not have slopes. So they do have slopes. It's just that they have an infinite amount of slopes. There's a slope here and here and here and here and here and here and here, and it gets steeper as it goes along. If you take calculus, you'll learn how to find the slope at any spot on the curve. Pretty cool. Secondly, which one of the cases got biggest the fastest? Case 4. So my question there is, what matters more? How many bunnies you start with or how many they multiply to? Yeah, so in exponentials especially, the start of it doesn't really seem to matter very much. What matters more is the multiplier. So remember, a, b to the x. A is the start, b is the multiplier. Um, just really quick, sometimes these graphs also start up at the top and come down. And that is if the multiplier is a fraction. So we're gonna have those probably next week. Okay, can you guys work on problems 6 through 10? There's the blue CPM books back here in the bookcase if you want those. Or use your Chromebook to get onto the ebook.